Good morning students, I am Dr.R.Suganya, Department of Computer Science with Cybersecurity. Today we will be seeing about how to secure the mobile key agreement. It is a technical review of authentication and also key establishment protocols from 4G to 5G networks. Okay, it explores the evolution of AKA protocols, which is AKA means authentication and key agreement protocols, which is the efficiency of ECC. ECC means ecliptic curve cryptography. Okay, so it is the efficiency of ECC in the key agreement process, and which is a 5G security posture, which is enhanced security feature. It introduces a 5G systems for a mobile key agreement. Okay. And there is a technical review agenda like cryptographic foundations, ECC efficiency, that is ecliptic curve cryptography, evolution of AKA authentication and key agreement, 5G security posture, mobile security risk and industry best practices. Okay, so here we have the involving cryptographic system, security evaluation and best practice, industry best practice analysis. Okay, so here we have the evolution of 3G PPP, which is authentication and key agreement protocols, tracing how mobile authentication has advanced from simple challenge response methods to complex mutual authentication frameworks, which is a 2G era legacy GSM aka, which uses a shared secret stored on SIM card for basic challenge response authentication, and 5G standard, which is like forward secrecy, which purposes enhancement focused on forward secrecy, ensuring that past session keys remain secure even if long-term keys are compromised. And next is that is the equivalent security, computational speed up. Okay, and also the year over year threats. So equivalent security here, it means achieve strong security with much shorter key lengths, which is advantages for resource constrained module devices, and computational speed up, which can help up to 15 times faster than RSA on mobile processing hardware. And year over threats here, 75% of increase in mobile malware, highlighting the growing need for efficient hardware backed security solutions like ECC. Okay, so here it is. And next is about the AKA challenge response cycle, authentication and key agreement challenge response cycle. So the first is authentication request. It is the UE sends us a request registration to the mobility management entity. It is MME, mobility management entity, and AMF, which is the authentication process. And next is about vector generation. So the home subscriber server or unified data management generates authentication vectors. Okay, and using the shared master key. And network challenge, which is the network sends a random authentication to the UE. Okay, and the UE verifies the network's authenticity using the authentication. UE means user equipment. Okay, so the UE computes a response based on RAND and sends it back to MME. Okay, and for verification against the expected network. And session established, that is the if RES matches XRES, the authentication succeeds and derives ciphertext and integrity keys, and it is used to secure user data and signaling encryption, which established a secure session. Okay, and next is about the security features of 4G and 5G. So 4G, the international mobile subscriber is sent in clear text exposing the subscriber's identity. Next, that is a permanent identity. And 5G, which is a subscription permanent identifier, which is concealed as subscription concealed identifier protecting user privacy. And primary key authentication, and which is like enhanced mutual authentication with stronger cryptographic methods like 5G AKA or EAP AKA. And home control, this has a limited home network control and which has enhanced home control in 5G. And key derivation, which uses a standard key derivation function. In 5G, it improves the key generations and security. Okay, and next is about 5G security functional architecture. AMF, that is access and mobility management function, and security anchor function, which manages access and mobility in the network, and it has a security anchor function. And AUSF, that is serves as authentication server in the home network, and it makes a final decision point for subscriber authentication. And unified data management, which has a strong long-term credentials, and it generates authentication vectors. A universal subscriber identity module or universal integrated circuit card, which is a temporal-resistant hardware which is embedded in the user device, and it securely stores a master secret key which is used for cryptographic operation and authentication within the network. And next is about modern risk and vulnerabilities like identify and tracking, network level attacks, and device compromise. So these are the three things. And next is about it is the slides which presents the key agreement techniques in mobile communication. It is which mandates ECC based on ECDH, which is Elliptic Curve Diffie Hellman, to optimize the battery life and processing power on user equipment. And next is SUPI, that is enable subscription permanent identifier concealment using the subscription conceal identifier key, and stored master keys in temper resistant hardware, okay, which is the universal integrated circuit card, and implement session receptions. So this image shows like the padlock made of wooden locks with a data cube, symbolizing the secure data protection through proper key management and encryption practices. Okay, so the future of mobile is like from some semantic secrets to robust 5G privacy. Key agreement remains a bedrock of secure mobile communication, and it is very critical to solve the trade-off between the performance and privacy